So we looked at student loans and compound interest. We noticed from the student loan website that the interest on an unsubsidized loan was 3.76% was your annual percentage rate. So we want to talk about how much money you would owe at the end of 4 years if you were to take out $6,500 and not make any payments on the interest, and how the different type of compounding changes how much interest you owe at the end of the 4 years. So we're going to start with what is our general formula for interest. And it's the amount of interest, or the amount in your account actually, is your principal, the amount of money you started with, times 1 plus your interest rate to the t, where your interest rate must be changed to decimals. So to do that, we're going to take our decimal point and move it twice. And so the rate we're going to use is 0.0376. Now this first equation here is looking at a yearly compounding, meaning they only calculate it once at the end of the year. That's not generally how most loans are calculated. Most of them are done monthly. So if we have daily compounding, that's 365 times per year. Monthly is 12 times per year. Quarterly is 4 times per year. Weekly would be 52. And continuously uses a completely different equation. We'll talk about that too. So we start with, if it's compounded daily, then our interest rate must be converted from a yearly rate to a daily rate, and that is by dividing my rate by 365. So my daily rate is 0.0376 divided by 365. My monthly rate is 0.0376 divided by 12. My quarterly rate is 0.0376 divided by 4. So whichever one it is, that's what we have to plug into our equation. And then T has to represent how many times it's going to get compounded over the life of the loan. So for example, for 4 years, the number of times it's going to get compounded if it's daily is 4 times 365, which is 1460, I believe. Monthly would be 4 times 12. Let's see, my pen's not working. 4 times 12, which is going to be 48 times. And quarterly would be 4 times 4, which would be just 16 times. So these are things that have to go in for R, the daily rate, the monthly rate, the quarterly rate, and the years has to be converted into the number of times compounded if you're not just looking yearly, and so this is what T ends up being. So let's go back. Our P, our principal, was $6,500. We had different rates depending, but our yearly rate was 0.0376, and T was 4 years. And then now we can look at the different types of compounds. If we want to know how much is in the account, if it's daily compounded, we're going to do 6,500 times 1 plus my daily rate, which is 0.0376 over 365, to the 4 times 365, that was 1460 power. If we want monthly, that's 6,500 times 1 plus 0.0376 over 12 to the 48. If we wanted quarterly, it's 6,500 times 1 plus 0.0376 divided by 4 to the 16. The exponent represents how many times it will be compounded over the life of the loan. And so this is where it becomes really important that you use your calculator correctly. And a lot of our calculators, we can just put all the information in, but if we miss one parentheses, the problem could be wrong. So you want to make sure you're plugging it in right. I'm going to plug it in a little bit at a time. Let's see. I'm going to do, come on. So 0.0376 divided by 365 is, that's not correct. 0.0376 divided by 365 is 0.000103 plus the 1 is 1.000103. I'm going to add 1 in my calculator, and then I'm going to raise it to the 1460 power. So I get 6,500 times 1.16229, and I'm going to times that by 6,500. I get 7,554.88. And if I want to know how much interest I paid, so that's the amount of my loan, my total amount, including the interest that I paid, I can subtract my original 6,500, and I get 1,054.88, or 89 if you round right. Monthly, I take 0.0376 divided by 12. We get 1 plus 0.00313 to the 48. I'll do that on my calculator, to the 48 power, and it's 6,500 times 1.16203. You can see the numbers are slightly different. It's not a huge difference in the amount you're going to pay on smaller amounts. This should be a 7. And that's 1,054 and 17. Oh, no, sorry, 53. 0.17. So you can see it's a little bit more than $1 when it's daily. And then quarterly, 0.0376 divided by 4 is 0.0094, and 6,500 to the 16 power is 1.1615. I'm rounding on my written work, but I'm not rounding in the calculator. And I just messed that up. Okay, let's see. 1.1615 times 6,500. And just make sure while you're using your calculator, you really check to make sure the numbers you're putting in is correct. And in this case, the interest is 1,049.75. So it's not a huge difference in the amount of interest that's paid depending on how it is calculated. But you need to make sure you're using the right equation, that your interest is divided by the right number, that you're using the right number of times that it's compounded for the life of that loan. And then in the end, when it's asking for how much interest you paid, it's asking you to subtract the amount that you borrowed. And then lastly, if it's compounded continuously, we use the APERT equation, where E is our Euler's number, and that's 6,500 times E to the 0.0376 times 4. And when we do that in my calculator, I'm going to do 0.0376 times 4 first. And so I get 6,500 E to the 0.1504. Raise the E to that power, I get 6,500 times 1.16229. It's not that far off of our daily compounded rate. It's maybe a couple of cents difference between compounded continuously and compounding daily. And so that would be the amount you owed at the end, and your balance, or the interest that was added to your balance, would be $1,054.94. These equations work with any type of loan. It doesn't have to be a student loan. It could be any type of interest, but you need to just make sure really carefully. If it's a 6% interest, your decimal is 0.06, not 0.6. If it's a 4.3% interest, you need to make it 0.043. Please just make sure that you convert your percent to a decimal correctly. All right, that's all I got. I hope this helps kind of you understand the different types of compounding and how that affects the different loans and their interest.